The question is, let f of x is equal to x square minus 2x plus 2 be a continuous function defined on x belongs to closed interval 1 comma 3. The point x at which the tangent of fx becomes parallel to the straight line joining f of 1 and f of 3 is. Four options A, B, C, D given. This question is from engineering mathematics, from the topic calculus, subtopic mean value theorems. Solution is the function is continuous. It is a second degree polynomial function whose differentiation f of, that is f dash x also exists, and f of 1 not equal to f of 3. F of 1 not equal to f of 3. Okay. So the tangent parallel to straight line joining f of 1 and f of 3. That is nothing but this is the geometrical interpretation of Lagrange's mean value theorem. Since the tangent that is tangent drawn at a point x belongs to open interval 1 comma 3, which is parallel to the straight line joining f of 1 and f of 3 of f of x is parallel to the straight line joining f of 1 and f of 3. So f of 1 means a, that is y coordinates given, the corresponding x coordinates, that is this is nothing but some coordinate name a 1 comma x coordinate 1, y coordinate f of 1. F of 3 means a point B having x coordinate 3 and y coordinate f of 3. So, which is the geometrical interpretation. Here I can write and f dash x exists at x belongs to open interval 1 comma 3, that is usually the interval denoted by a comma b. Interpretation of Lagrange's mean value theorem, LMBT, that is short form of Lagrange's mean value theorem. Therefore, by Lagrange's mean value theorem, comma, we have f dash x, or you can write f dash is equal to f of b minus f of a divided by b minus a, where this x is a point in the open interval 1 comma 3. So what is f dash x? 2x minus 2, ordinary derivative with respect to x. F of 3 square 9 plus 2 11 minus 6, that is 5. F of 1 1 plus 2 3 minus 2, that is 1, divided by 2. This one. F of 3 is put x is equal to 3, 9 minus 6 plus 2 is equal to 5. 5 minus 1, 4, 4 by 2, 2. So therefore, x is equal to again 4 by 2, which is nothing but. So this value of x2, which is lies between 1 and 2. So that means our assumption, that means our guessing is correct here. Lagrange mean value theorem. Okay. So the answer is 2. This is, that means accordingly, option is C. This is the end of the question. The question is, consider a binomial random variable x, full stop. If x1 comma x2 comma so on xn are independent and identically distributed samples from the distribution of x with sum y is equal to summation I is equal to 1 to n xi, comma, the distribution of y as n tends to infinity can be approximated as four options ABCD given. This is xi. This question is from engineering mathematics from the topic probability and statistics, subtopic distributions. That is binomial normal distributions. Solution is, so we know that sum of n independent binomial random variables is also a binomial random variable having small p is the probability of success, which is same for each independent random variable, and n is the number of tries. But here n tends to infinity. That is sum of infinite binomial random variables. We know that normal distribution is the limiting case of binomial distribution whenever n is indefinitely large. That is n tends to infinity. Okay, this is a conceptual question. Since sum of independent binomial random variables is also a binomial random variable. So in mathematical approach, that is, if x1 follows binomial distribution of n comma n1 comma p, and x2 is also binomial distribution with the parameters n2 n1 n2 are the number of independent tries. P is the probability of success for any single try, that is probability of event in any single try. And x1 comma x2 are independent random variables, then x1 plus x2 is also binomial distribution, that is follows binomial distribution with parameters n1 plus n2 comma. This is the formula based on mathematical approach. This is a conceptual verbal approach. Next, y value given summation I is equal to 1 to n xi, the distribution of y as n tends to infinity. Okay, and normal distribution is the limiting case of binomial distribution if n is indefinitely large, neither p nor q are small. So that is n tends to infinity. Here y is equal to summation I is equal to 1 to n xi is nothing but x1 plus x2 plus so on plus xn. So already x1, x2 are given independent and identical samples from the distribution of x. That is binomial here given. So is also binomial distribution. B stands for binomial distribution. Now y as n tends to infinity, that is implies distribution of y is sum of infinite binomial random variables, but should be a normal distribution. Y as n tends to infinity, that is x1 plus x2 plus so on xn plus so on is a, because limiting case. Normal distribution is a limiting case. Please underline. Is a normal distribution. So here I can write instead of here, therefore this one y is a binomial distribution, but in the limiting case it becomes a normal distribution. Okay, so that means therefore y can be approximated as n tends to infinity as normal. Okay, so the answer is normal. That is sum of infinite binomial random variables is a normal distribution. So accordingly, option B is the answer. This is the end of the question. The question is the Dirac delta function delta of t minus t naught for t comma t naught belongs to R has the following property. Integral a to b phi of t into delta of t minus t naught dt is equal to phi of t naught a less than t naught less than b 0 otherwise. The Laplace transform of the Dirac delta function delta of t minus a for t greater than a, that is for a greater than 0, L of delta of t minus is equal to capital F of S is. This question is from engineering mathematics from the topic Laplace transforms. 4 options given ABCD. The solution is so that is we know that generally Dirac delta function is also called impulse function is equal to 0 for e not equal to a infinity for e is equal to a. Here a is nothing but t naught. You can compare like that. Okay, is unit impulse function or Dirac delta function such that st means such that integral 0 to infinity or minus infinity to infinity delta of t minus c dt integration dt is equal to 1. Okay, it is the limiting uh, form of f epsilon of t minus a. You can refer that BTech textbooks, standard books. That what is the limiting case? That unit impulse function. If the large forces acting on a small particle, the product of force and time. The large forces acting in small interval of times. Okay. The product of force and time is called impulse, and the limiting form is called unit impulse function. So Laplace transform of delta of t minus a is equal to e to the power minus as. So this is the formula. Okay, standard formula is standard result or form. Usually instead of t naught, that is here given a to b, function of phi of t, delta of t minus t naught. The t naught is a number between a to b. Just integrating with respect to this, that answer is obtained by substituting t is equal to t naught in this function phi of t. This is phi of t naught if a less than t naught less than. Okay, this is not interested actually, is equal to 0, otherwise other values of t naught. So the answer is e power minus as. Accordingly, the option is C. This is end of the question. Standard result directly. The question is, let C represent the unit circle centered at origin in the complex plane and complex variable z is equal to x plus iy. The value of the contour integral over C cos h3z divided by 2z dz, where integration is taken counterclockwise is 4 options A, B, C, D given. This question is from engineering mathematics from the topic complex variables and subtopic complex integration. So the curve is a closed curve. Unit circle means radius 1. Center origin already given. Counterclockwise given direction of the curve C. Okay. So solution. Equation C is mod z is equal to 1. That is circle equation in the complex plane is mod z minus a is equal to r. Here r is the radius, a is the center. Here center origin. Okay. Now find the singular points of this integrand cos h3z by 2z. The SP, that is short form of the singular points, are given by equating denominator to 0. That is 2z is equal to 0 gives implies z is equal to 0. This 0, whether it is lies outside or inside, how do you check? Substitute this z value in the curve equation. Whenever left hand side value less than right hand side value, such a singular point lies inside the curve. And if the left hand side value greater than right hand side value, such a singular point outside the curve. So if I put here z0, mod 0, 0. So 0 less than 1. So this is lies inside. Therefore, the given integral along the closed curve C can be written as or expressed as cos h3z divided by 2z dz is equal to integral over C cos h dz divided by 2, put in brackets, all divided by z. Z can be written as z minus 0. Just I want to compare by Cauchy integral formula, or you can apply Cauchy's residue theorem. So when a singular point lies inside the curve, such singular point usually denoted by small a. And the numerator function is denoted by f of z usually. So this is small a, and this numerator function is denoted by f of z. Okay. Now so this is equal to 2 pi I into f of 0. That is function f of z at z is equal to 0 multiplied by 2 pi I since by Cauchy's integral formula. Cauchy's integral formula. So this is equal to 2 pi I into, put z is equal to 0 in the function f of z. So cos h into 0 divided by 2, which is nothing but cos h 0 value 1, 2 to cancel, pi I into cos h 0. Cos hx is e raised to x plus e raised to minus x by 2. So this simplifies to 1. So finally 1 into pi I. So the answer is pi I. Accordingly, option A. This is end of the question. The question is, if y of x satisfies the differential equation sin x into dy by dx plus y cos x is equal to 1, comma, subject to the condition y of pi by 2 is equal to pi by 2 and y of pi by 6 is. Four options A, B, C, D given. This question is from engineering mathematics, from the topic differential equations, subtopic first order equations. The solution is, so in general, any of the problems, not all the problems, that first order, first degree differential equation solvable by variable separable method, linear equation method, Bernoulli equation method, any one of these, exact equation, or some problems cannot be solved by any method. So this is not variable separable form. Now to check whether it is linear or not, here the dependent variable, the derivative of y with respect to x, y is dependent variable, we can take. So y power 1, no other y terms, and dy by dx having power 1, y and dy by dx are not multiplying. That means this is a first order, usually whenever these conditions satisfied, which is a first order linear equation. Okay, so to solve it by linear, we should make derivative quotient is 1. That means we should divide both sides by sin x. DE means is the short form of differential equation. Can be written as dy by dx plus cos x by sin x. You can write cot x into y 1 by sin x cosec x. Equation 1 is first order linear equation in pi variable. This is usually denoted by p, and this right side term denoted by q. That is the standard form of first order linear equation in y is represented as dy by dx plus p into y is equal to q. The next step to find the solution is IF, that is integrating factor e to the power integral p dx. So cot x integration with respect is log sin x. That is cos x by sin x. I can write cos x, which is looking like integral f dash x by fx. So answer is log f of x. So e log cancel, which will become sin x e to the power log of any function, giving that function of. So the next step solution. There solution is, because it is linear equation in y variable. Okay, so y into if is equal to integral 2 into if integrating with respect to x, that is dx, plus, which implies y times sin x is equal to integral q into if cosec x into sin x. Cosec x means 1 by sin x, so we will be getting 1 dx plus c. 1 dx integration is x plus c. Let us take equation 2. Use the given conditions using y of pi by 2 is equal to pi by 2. That means pi value pi by 2. And x is equal to pi by 2. Substituting this condition into in equation 2. comma equation 2 gives sin 91. So pi by 2 into 1 is equal to pi by 2 plus c. This simplifies to c is giving 0. Therefore, back to the solution, that is equation 2, y sin x is equal to x. Now, they are asking y of pi by 6. So from this, find y value. That is x divided by sin x. Okay. So, at x is equal to pi by 6 implies y is equal to pi by 6 divided by sin pi by 6. Sin 30 degrees is 1 by 2. So, this is simplifies to pi by 3. Is the value of y of pi by 6. So, the answer is pi by 3. Accordingly, option A. This is end of the question. The question is, consider a vector P in two-dimensional space, that is 2D vector. Let its direction counterclockwise angle with the positive x-axis be theta. Let P be an eigenvector of a 2 cross 2 matrix A with corresponding eigenvalue lambda, lambda greater than 0. We denote the magnitude of a vector B by that magnitude symbol length V or norm V. Identify the valid statement regarding P dash where P dash is equal to A into P. 4 options A, B, C, D given. This question is from engineering mathematics from the topic linear algebra, the subtopic eigenvalues, eigenvectors. So usually matrix denoted by capital A, eigenvector denoted by capital X, eigenvalue denoted by lambda. But instead of capital X, it has given small p eigenvector. Two-dimensional space. Solution. So this is called norm or length or magnitude of a vector V. Okay. So P dash given AP. Let us find that is first of all, we know the relationship between a matrix and eigenvector and eigenvalue. We know that A into small p is equal to lambda into small p equation, where lambda is eigenvalue and p is corresponding eigenvector of matrix A. Okay. Now, this is A is 2 cross 2 magnitude P dash. Okay. So P dash given P dash is equal to matrix A into eigenvector is equal to magnitude A into small. So this can be written as magnitude AP can be written as lambda into lambda is a constant, P is a vector. So magnitude is for vector or matrix only. Vector means here 2D vector. So lambda times I can write magnitude of. Okay. So finally, therefore, magnitude of a vector P dash is same as lambda times magnitude of the vector. Okay. Now, I mean option C Option D, you will be having the similar notation this one. And we decide the direction of V dash is theta or not. Same. Vector P and lambda into P have same direction. For example, let us compare with vector algebra. I cap, you know the direction of I cap along x-axis. The direction of a number in I cap is 2i, 3i, which are in the same direction only, have same direction. Therefore, P, lambda P means AP, that is P dash. P dash, P dash is nothing but AP. AP is nothing but lambda P, have same direction. Already direction of P is given theta. Yes, see, this is a vector P. Let its direction given theta. Therefore, direction of P dash is theta. This is the second one, and this is the first one. Combining these two, magnitude of P dash is lambda times of magnitude of P, direction of P dash is theta. Which option is suitable? So, accordingly, answer is option C. This is end of the question. The question is, the ordinary differential equation dy by dt is equal to minus 5y subject to an initial condition y of 0 is equal to 1 is solved numerically using the following scheme: y of tn plus 1 minus y of tn whole divided by h is equal to minus 5 times y of tn, where h is the time step, comma tn is equal to nh, comma n is equal to 0, 1, 2, etc. This numerical scheme is stable for all values of h in the interval. 4 options A, B, C, D given. This question is from engineering mathematics, from the topic numerical methods, subtopic numerical solution to ordinary differential equation, that is also called stability analysis. So please underline stable. It is nothing but stability analysis. So in place of x, it is given t variable. Okay, there is no problem. So dg differential equation is dy by dt is equal to minus 5y. So usually the first order differential equation can be represented by dy by dx is equal to function of x comma y, but here in place of x t, so the right side now denoted by function of t comma y. So this is function of t comma y, where t is absent because right side only minus y into y. Okay, that is the first observation. So usually stability analysis given by Euler's, that is forward Euler's formula. The forward Euler's numerical scheme is iterative scheme. Iterative formula or scheme is y of, that means yn plus 1. This is our suitable notation, but it is given yn plus 1 means the value of y at xn plus 1. In place of x, that is t variable. Yn plus f of tn comma yn, which is nothing but yn. Here in place of f of t comma y, put t is equal to n, y is equal to yn, minus 5 times yn. So that means 1 minus 5 yn Okay, so h is missing here, h times. So we are not required to write this one. Yi plus 1 is equal to yi plus h times f of xi comma bi, but in place of I, it is given n notation. So this is yn plus h. H is usually called step size or time. Okay, that is. So here yn plus h into, in that function, put t is equal to n, t is equal to yn, you will be getting minus 5 times yn. Okay, so let us denote this is equation 1. Now yn plus 1 means y of tn plus 1, that is the y value at tn plus 1. Yn means the y value at tn. Okay, minus 5 times h times yn means the value of y at tn. So this can be written as y of tn plus 1 minus, shift the right side first term to the left side, it will become minus y of tn divided by h is equal to minus 5 times y of tn. So this is that equation. Okay, that means our Euler's forward formula can be written as the given scheme, this one. But not interested, just why they have given, they represent like that. For that purpose, I have brought my formula into that one. Now, for table, that means equation 1 can be written as, now, usually for stability analysis, your Euler's forward iteration formula can be expressed as yn plus 1 is equal to yn, that is E into yn plus hk. What is that E? What is that H? What is that K? That I am expressing is 1 implies, or 1 can be expressed as one can be written as, or 1 can be expressed as yn plus 1 is equal to E into yn, where E is equal to 1 minus h1. Okay, so actually yn plus 1 is equal to E into yn plus h into k, where k is a term, k is a constant or contained ti terms. That is the standard form of writing the Euler's forward iteration formula before making the stability analysis, before making that stable. Okay, so for stability or stable, comma, we have the condition mod E less than or equal to 1. Okay, so you can write here plus h times k, and k is equal to 0, that is k is constant or contain independent variable terms, ti terms. That means instead of I notation, it is given n iteration scheme, n notation. Here this is n. Okay, so E into yn plus hk, k is a constant or contain n term. Okay, so that means here constant 0 k, because it is absent, E into yn plus hk. If I compare, so this can be written as again yn into 1 minus h pi. So this is E value. And hk, better write down. Otherwise you will get confusion. This one, take care. I am writing again here. E into yn plus h times constant k, comma, where E is equal to 1 minus h pi and k is equal to, so mod E, that is mod 1 minus h pi less than, since modulus inequalities, mod x less than some a, which can be written as without modulus minus a less than x less than a. So using this, I can write this is minus 1 less than 1 minus h pi less than 1. So finding it, first eliminate 1, subtracting 1 for all the three terms, which can be written as minus 2 less than minus h pi less than 0. Multiplying by minus all the three sides, 2 greater than, when we are multiplying by minus sign to an inequality, the inequality will be reverted. The inequality symbol will be reverted. Okay. So 2 greater than h pi greater than 0. So dividing by pi, pi is a constant which is a positive constant. When you are dividing a positive number, the inequality will be same. So this becomes 0 less than h less than 2 by pi. So the h maximum value is 2 by pi. So that is, this is the required interval. Okay, is stable for all values of it. Is the required interval for finding that h is the required interval for making the given numerical scheme stable. Required interval. So 0 less than h less than 2 by pi is answer accordingly option A. This is end of the question. The question is, the value of limit extends to 0, 1 minus cos x by x square is 4 options A, B, C, D given. This question is from engineering mathematics, from the topic calculus subtopic limits. The solution is, so limit, this is either standard limit or using the methods, that is 1 minus cos x upon x square. So when by direct substitution, putting x equal 0, cos 0, 1, 1 minus 1, 0, denominator 0 square 0, 0 by 0 form is 0 by 0 form. So you can apply L'Hospital's rule. So this is according to L'Hospital's rule. So that is differentiate numerator as well as denominator with respect to x using L'Hospital rule. Limit extends to 0, 1 derivative 0, cos x derivative minus sin x, x square derivative with respect to x is 2x. Since by using L'Hospital's rule. So now this can bring as half times limit extends to 0, sin x by x, which is a standard limit, is equal to half into 1, is equal to half. So this is, since limit extends to 0, sin ax upon x is equal to e. That is the answer. So, but in place of a, we have half. This is alternate method. Second method. This is also the question, the given limit, which is again a standard limit. Limit extends to 0, 1 minus cos ax, a is a constant, upon whole divided by x square is equal to a square by. So using that, you will be getting 1 by 2. So the answer is 1 by 2. That is here. Therefore, limit extends to 0, 1 minus cos x divided by x square is equal to 1 by. So accordingly, the option is D. This is end of the question.